Okay, we're in section 15 of the notes, and we're going to go through the examples. This is on higher order derivatives. Certainly, I realize there's answers provided for you, but you'll see me working at the whiteboard. Certainly when I'm writing up notes, the first thing I do is I write my work on a piece of paper, and then of course I type it up. So basically, what you're seeing is the missing piece of my typing, which is me on paper. I'll be on a whiteboard to do that. These questions, for the most part, they're a little bit tedious. I will be honest with you, but the only question that really should provide, question for pause would be this one over here about differentiating what's what in the picture. Now, granted, there's color given over here. The reason that I want to make sure you're clear about which curve is which curve, they want me to separate these things out. One being the function f, the other one being its derivative, and then its derivative of a derivative. So a function, f prime and f double prime. All right, let me go to the whiteboard. And as I go to the whiteboard, I'll do the questions separately. Again, you need to study this material, but the bottom line, after studying the material, you need to get busy with homework. And that can be tough, by the way. For a lot of students, they wait till the last minute to do something and generally do a hack job. When they get to exams, it doesn't work out well for them. Be proactive. Be on top of this material after it's presented to you. Okay? So let's go to the whiteboard. And as I do that, I'm hoping you have a piece of paper and pencil and you're willing to work along with me. But again, it may go too quick for some students. Not everyone's at the same speed, so to speak. So the bottom line over here, if I'm looking at this one over here, and someone says, can you take its derivative? I think so, and I'll put down what I mean by that. And it might be difficult for me, but I can write down y prime. So what's y prime? I'm going to be using the quotient rule, all right? And as I do that, I realize they want more than y prime, they want y double prime. So what do you do? Square the bottom. Bring the bottom to the top. Times root of the top minus the top times root of the bottom. Well, that turned out to be pretty easy, didn't it? And what do you get over there? Well, you get 1 on top, and then you get 1 minus x squared on bottom. What I would do in the answer key is I would look at it, and I'm seeing that right over there. So I think I did go with that. Now what I have to do, this is more difficult, all right? More difficult. So I'm going to do the second derivative. Now do the second derivative, it's more difficult. We'll look at the key later. What do I do? Well, I got to square the bottom. So what's that going to be? 1 minus x to the 4th power. Bring the bottom to the top and leave it alone. Now what I got to do? I got to take the derivative of the bottom. I want to point out what the bottom is to me. It's 1 minus 2x plus x squared. Its derivative would be minus 2 plus 2x. Don't panic yet. Okay? Minus, something, I think I just made a mistake. And let me just see what I just said I was going to do. I'm so sorry about that. I did something and I did it, but I wasn't thinking. I got to erase that. I got confused myself. Sorry about that. So let me repeat what I got spaced out, and it happens sometimes. So square the bottom, bring the bottom to the top, times the derivative of the top, which is 0. Sorry about that. Minus the top times the derivative of the bottom. Well, this is the bottom. What's its derivative? That's where I got spaced out, by the way. Minus 2 plus 2x. All right. Someone's going to say, what are you going to do now? I guess I got to simplify that. So, and again, we'll look at the key later. 1 minus x to the 4th. And what do you get over there? You would get 2 times 1 minus x. And what does that simplify to? 2 over 1 minus x cubed. I'm going to say it's second derivative. Let's take a look. And I got it. All right. Was that tough? Yeah, that was tough. Can you make a mistake? Get spaced out, you can. All right, I got spaced out on that one. But I made my corrections. All right, let's look at number 2. And let's take a look at this number 2. So you got h of t. And what's that? That's e to the t over t. Now they want h double prime at 3, but I need to find h prime first. Well, quotient rule, right? What do you get? T squared. Let's say bring the bottom to the top times the root of the top minus the top times the root of the bottom. Well, you know what I'm going to do? I'm going to simplify it. And what would you get over there? You get e to the t over t minus e to the t over t squared. I'm going to take its derivative now, second derivative. It's work though, I know that. And the problem with work is mistakes are really easy to come by. This is why you need to practice before you get to exams. So it's going to be t squared t times e to the t minus e to the t times 1. First term's done. T4 t squared et minus et times 2t. All right, we got some work over here. And what I'm going to do is h double prime and 3. Let's write this down. 9 3e cubed minus e cubed minus, oh boy, this is going to be 81, isn't it? And then what are you going to get? 9e3 minus 6e3. Let's keep going. 2e3 over 9 minus, what'd you get over there? 9 minus 6 is 3, right? Over 81. I'm going to reduce and I'll add them together. 2e cubed over 9 minus e cubed over 27. Common number is 27. You're going to get 6e cubed minus e cubed, which can be 5e cubed over 27. Do mistakes happen? All the time. And that's why you need to be really careful about looking at the answer. So I got the answer. I definitely got the answer. Now, what I'm going to claim over here is I'm looking at their second derivative and I'm looking at mine. And I notice they look different. Now, by the way, on exams, I wouldn't be doing this, but I want to do it for you. Now, someone says, why do you want to do it for you? I want to see if I can match their answer. And this is part of my learning, all right? So I'm going to write down h double prime, t. I'm going to simplify. This would be t, e to the t, minus e to the t over t squared, minus, I'm simplifying the second term now. I'm going to divide by t. So you get t, e to the t, minus 2e to the t over t cubed. I'm going to get a common denominator now. Common denominator would be t cubed. You would get t squared, e to the t, minus t e to the t, minus t e to the t, plus 2 e to the t. I'm going to combine terms together. And again, on exams, I would not be doing this. When you're doing homework, though, it's much more calm. You're not in a rush to go anywhere. At least I hope you're not. Okay. Let's see if we match their answer, by the way. And what's their answer? T squared e to the t, I got that. Minus 2t e to the t, I got that. Yeah, we did remarkable. We're matching that as well. All right. Let's look at the next one. The next one, I want to be honest with you, for a lot of students, is difficult because now they're asking for an abstraction. And the abstraction is this: they want to know what the nth derivative is. What I would recommend you do is start writing them down. This is an important skill set to acquire, and it's what's known as a pattern recognition. Pattern recognition can be very difficult to determine if things are all over the place. So I want to try to keep it nice. And this is x to the minus 2. So I'm going to try to keep it nice. Try to make a prediction if I keep it nice and orderly. So what do you have here? Well, this is minus 2, and then it's going to be t to the minus 3. Let me put down f double prime. And I'm not going to multiply. I'm just going to write this. It's going to be 2 times 3 x to the minus 4. Let me put the next one down. This is something you did in Math 120, by the way, pattern recognition. You wrote down a sequence and you predicted what the pattern was for the sequence. This will be minus 4. It's going to be 2. I'm sorry. I'm going to write a little differently than that. I want to keep it in the same order. I'm going to say minus 2 times 3 times 4, x to the minus 5. Let's do the next one. Now, when we exceed 3, we use a numeral 4. Remember, it's really hard to count hash marks. What's this going to be? 2 times 3 times 4 times 5, x to the minus 6. Now, by the way, you could do this all day long, but I'm starting to realize I think I may have a pattern here. Right. So I want to chase one rabbit at a time. I'll tell you what the rabbit I'm going to chase over here. It's the derivative and the power. 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 By the way, this is 0 and the power. I'll take a look at it, see if I can do that. So I can see if I can predict it. Just the power. I know it's going to be x to a power, and it's a negative power. Whoops, I didn't mean to do that. Let's take a look at it. I'm going to point out to you. Nothing gives me minus 2, or I said 2. 1 gives me 3. 2 gives me 4. 3 gives me 5. 4 gives me 6. It looks like I'm increasing that by 2, right? So I'll write that down for you. I'm increasing it by 2. So I'm going to say n plus 2. I'm just doing one thing at a time. Let's see if that worked. 0 would give me 2. What's minus 2, of course. Then I get minus 3, minus 4. Looks good. All right. Again, these are things you studied in Math 120. Now what I'm going to do is I'm going to look at the number, not the sign, just the number. This is going to be 1. Whoops, sorry about that. This is going to be 1. This is 2. This is 2 times 3. This is 2 times 3 times 4. This is 2 times 3 times 4 times 5. What do I notice about that? They're factorial. And what's it going to be? It looks like n plus 1 factorial. For example, if you look at 4 here, that's 5 factorial. This is 4 factorial. I'm going up by 1. This is 3 factorial. This is 2 factorial. And that's going to be 1 factorial. All right. 0 gives me 1. 1 gives me 2. 2 gives me 3. I'm talking about factorials now. 3 gives me 4. 4 factorial. 4 gives me 5 factorial. So I'm going to say n. Whoops. Let's go back to black ink. N plus 1. We'll check in the key later. The other thing I have to worry about is the sign in the problem. And what am I noticing is positive. Let me go back to the highlighter. Positive, negative, positive, negative, positive. It's alternating. And how'd you do that in Math 120? You put a minus 1 down to a power. What power though? Typically n. Well, if n is 0, I would get positive. If n is 1, I'd get negative. This works out beautifully. So I'm going to write down my answer. I'm going to try to make it nice and neat, and then we'll look at the key. And this is tough, Bob. I'm not saying it's easy. All right, let's look at the answer. And what did they get? They wrote it a little differently, I'll tell you honest with that. I see the minus 1 at the end. I see the n plus 1 to factorial. What did they do? They wrote this way. They didn't like the negative power. Kind of reminds you what you might have done in Math 100. And that's fine. We got the same answer. Both answers are the same. All right, let's go to the next one. And I got to be honest with you, these are a little bit annoying. As I'm looking at them, though, they're saying I should be able to differentiate these guys over here. Now, the way I do the problem may be different than the way you do the problem. But what I do is I look for derivatives that would be 0. and that means a horizontal tangent line. So I'm going to put down over here that if I were doing horizontal tangent lines, I'd get a horizontal tangent line here. And I'm looking at the black curve, by the way, and I get a horizontal tangent line over there. What do I mean by that? If I look at a tangent line there, it's like this over here. What's the slope correspond to there? 0. So if you do that, that would be 0. That would be 0. The derivative about to is 0. Let me talk about this now. And again, I'm not saying it's easy for you. I'm looking at the black curve. What's the slopes along here? They're all positive, right? They're all positives until I get to that. And then it hits 0. What is about this red curve over here? They're all positives. Now, I want to point out over here, it's really steep. It gets less and less steep. So less positive. And it becomes smaller. So I'm going to say, looking at this, the black curve looks like F, and the red curve looks like its derivative. All right, I'm still not even looking at the green one yet. Let's keep going. Over here, what's the signs of the derivatives over here? Well, the things are all going to be negative slopes. This is all negatives. Where's the maximal slope over here? Somewhere over here. And I'm seeing that right away. It's most negative over there, that slope. What happens now? When I get this over here, the slopes become positive over here. And I'm seeing that over there. All right. So I'm going to say the black curve, this curve over here looks like F. And the red curve looks like F prime. Now I want to look at the red curve and see if it's related to the green line. What do I notice about that over there? Well, you know what? This is a horizontal tangent here. So what I'm going to do is I'm going to trace up, and I see the 0 there. Now let's talk about this one step at a time. We're looking at the red curve now. All the slopes are negative. If you look at the green thing, it's all negative over here. All the slopes are positive. Look at the green thing, all slopes are positive over there. So what am I going to say over here? F double prime. So what I do, I differentiate it. Now, of course, let's read it. What does it say? The black curve is F. I did that. It says the red curve is F prime. I did that. And the green curve is F double prime. This makes sense. I'll tell you why. The F curve is cubic. Looking at it, right? The F curve is cubic. When I say that, the black curve, what's this thing over here? It's quadratic. It's a parabola. If you differentiate a cubic, you get a quadratic. And what's F double prime? It's a line, which is linear. Differentiate a quadratic, what do you get? You get the line. Certainly makes sense. All right, here comes the trouble. All right, someone said, what's the trouble? This. You got to get busy with it. You have to do that. So someone says it's too difficult. You've got to meet the expectation of putting work in it. Time and effort is going to go places. All right. Calculus for a large number of students is they think they understand it and they do very little effort on the homework business because they say, I understand what you've done in class. I think I can do that when I get to exam. Thinking doesn't matter when you get to exam. You need to practice before you get to those exams, and we give you plenty of opportunity to do so. Please do that homework. If after doing the homework that you got questions or concern, bring them to my attention, and I'll be more than happy to help you. I also publish videos on the homework. If you want to watch me do homework, you can watch me do homework too if you like.